These are definitions for converging and diverging cycle diagrams. The direction of motion in these two is out of the center, and the direction of motion of these two is into the center. And these two, and the columns are the chiralities. They're two different isomers of the same or symmetric process. This one brings stuff into it, this one brings stuff out of it. So hypothetically, I could put stuff into it, it would collapse to a delta. That delta would then be passed up by some means, and it would spit out some value from that delta. It would give it a point. If T1, if this is the diagram I end up with, I'm going to redraw it. This recursive process makes the separation zero, special zero. Note that one of the apparent chiralities to this is the unwinding of this process, the out of versus the into. I think when it converges onto a single point, I could safely say that that point has higher resonance, sort of like saying collapsing the wave function makes it more real. As it starts to collapse onto a single point, onto a single object, it becomes more real. And from that respect, it is more resonant in the physical world as a fixed object. But it lacks the dynamic character of an actual resonance, where there's movement within a system. Most likely, achiral objects map to achiral objects on large scales. This is because achiralities grow in number as objects get larger. Larger objects tend to be achiral, but at small scales, objects tend to be chiral. Small objects tend to be chiral, and as they get smaller, the chances of them being chiral go up. So C, in this case, tends towards COC, or two different chiralities linked by some relation, and that relation breaks it up into something that is chiral and chiral. If the order of outputs is independent of the order of inputs, then the expression is chiral. If output order changes with changes to input order, then the expression is achiral. It's a definition of chirality for an operator, but also for any COC. For all chiral, there exists a map to chiral. There exists a map to chiral. So chirals can definitely be combined to produce chirals. And large chirals tend to be able to be decomposed into smaller chiral chunks, or smaller consistent chunks. So going with AC as inconsistency, then for all consistencies operating with consistencies, there exists an arrow to a consistency. I'll say it again. For all consistencies operating with consistencies, there exists an arrow to a consistency. There's a map to some third consistent figure that combines these two in some fashion, even something as simple as proximity, and locking in their proximity and then checking their chirality. And when we add them together, we get back our inconsistent system. A chiral operator is demonstrated in this case. You see that the order in which the inputs go together causes a change in the order in which the outputs go. Input order changes output order. So the expression is chiral. Adding these two possibilities together, I get chiral. And when I add two achirals, I'm getting a chiral here, but it's a different chiral than the one I started out with. It's enough for now.